For a quantum system whose state is given in terms of an orthogonal set of three vectors as psi equal 2 times ket 0 plus square root of 5i spin up, ket times spin up times ket spin up plus 4 over I times ket 4. So that A normalize this state. We have to normalize it. So our point of interest, the first thing we want to do is to calculate for the norm, which is equal to the absolute square, the sum of the absolute square of each coefficient here. So we are going to square 2 absolute square of 2 plus absolute square of square root of 5i square root of 5i absolute square plus absolute square of 4 on I. 1 on I is equal to negative I. So this term becomes 4 negative I. So let's say negative 4i squared. But once we are dealing with absolute values, definitely this term will become positive. Okay. So squaring 2 gives us 4 plus squaring this term right here. If we square I itself is equal to square root of minus 1. So if we square it, it's going to give us minus 1, making this whole term minus 5. But the absolute sign will cover all of those effects. So we are going to get 5 here plus square of this is going to give us minus 16 bar. Since we are dealing with absolute values, it should be 16. So now let's add everything up. So in simple term, once you are dealing with absolute values, don't let this complex term here confuse you. So once we take the absolute value, generally it will cover everything. So norm equal 4 plus 5 plus 16, and that turns out to be 25. Now that we are done with our norm, we calculate for our normalization constant. And normalization constant equal 1 over square root of norm. And our norm is 25. So this is going to be 1 over square root of our norm here, which is 25, square root of 25. Going to give us 1 over 5. Square root of 25 gives us 5. Right? Now that is the second step. The first step we calculate for our norm. The second step we calculate for the normalization constant. And the last step is to multiply the state that was given to us, to multiply the normalization constant throughout. We were given psi, equal to, this is the term. So we are multiplying the normalization constant throughout. Let me bring it here over 5. Multiplying everything. So 2, 0 plus 5i spin up plus 4 on I, 4. Okay. So if we multiply 1 over 5 throughout, 1 over 5 multiplied by 2 is only going to affect the coefficient. So 1 over 5 multiplied by 2 is going to give us 2 over 5. Then you write everything as it is. Plus 1 over 5 multiplied by 5i is going to give us, this should be square root of 5i. So square root of 5i all on 5 spin up 8 plus 1 over 5 multiplied by 4 on I. So it's going to give us 4 on I, 4 on 5i, 4. Okay. So this is our normalized state. Then how do we prove that? Just take the coefficient the absolute square of the coefficient. So we have 2 over 5. We are taking absolute square plus square root over 5 of 5I on 5 absolute square as 4 on 5. 4 on 5I absolute squared. So squaring this gives us 4. Squaring this gives us 25 plus squaring this is going to take care of the I and the square sign. So we are going to get 5 over 25 plus squaring this gives us 16. Squaring this will give us 25. So that should give us 1. So normalize. That is it for this problem. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.